I want you to think about a bushel of apples. Or maybe 2 bushels of apples. I'm going to call the first bushel A1, and A doesn't really mean anything. It's just a term. And in this example, it stands for apples, but it could be any other letter or anything. But the 1 just tells you that it's the first bushel. So the second bushel I would call A2. Maybe there's a third. I'd call that A3, and you can probably see the idea. A4 is the fourth bushel, and A5, and so on and so on and so on. This is called a sequence. And in this example, we have a sequence of apples, but it might just as well be a sequence of numbers. We're going to be concerned with what happens in the future. And so if you look at the one all the way on the right, it might be the 10th bushel of apples, or the 99th, or the 26th, or anything. We don't really know sometimes which bushel that is. So we use a variable like n to say it's just the nth bushel of apples. Maybe it's the 10th, maybe it's the 20th, I don't know. So what about the bushel right before that? What comes before n? N minus 1. So think about it. If n was 20, then we're talking about the 20th bushel of apples. The one right before that, 20 minus 1, is 19. So what comes right before that? Well, right before n minus 1 is n minus 2. We're going to need to talk about the bushels in these terms sometimes. We're going to talk about some term in the future in terms of something in front of it and something in front of that. What we like to do, though, is look at numbers. So let's say that the first bushel of apples has 10 apples in it. And that doesn't give us a whole lot of information, but think about the second one. Let's say there are 12. Okay, I'm starting to get an idea of what's happening. And then the third bushel contains 14 apples. By now, you probably can predict what's going to be in the fourth bushel, 16. And by now, are you getting it? Do you know how many are in the fifth bushel? 18. Okay, great. This is called an arithmetic sequence. An arithmetic sequence is where a certain number is being added. In this case, you probably figured out that to get from one number to the next, you're just adding 2. So if we're adding a number, plus 2, plus 2, plus 2 every time, or subtracting a number, minus 5, minus 5, minus 5, if it's the same thing every time, if it's added or subtracted, that's called an arithmetic sequence. So a couple of examples. Number 1, find the common difference. All they're asking you to do is look for the pattern. The first number is 21, and we're going to the second number is 29, and then 37, and then 45. All you have to do is figure out how you're getting from number to number, and it looks like you're adding 8 to get from one number to the next. And so the common difference, D, equals 8. Number 3, find the 3 terms in the sequence after the last given one. I like to think of it like this. Fill in the blank with the next 3 numbers. Well, it's really similar. We want to figure out how we're going from number to number. And it's probably easier to see about right here that we're adding 10 every time. Add 10, add 10, add 10. And so if you continue that pattern, you can add 10 and find the next numbers 33, and then 43, and then 53. Problem 5, same deal. Find the next 3 terms in the sequence. So again, you have to figure out what the pattern is. How are they getting from number to number? And in this case, it looks like they're subtracting 5. Negative 11 minus 5 is negative 16. Subtract 5 to get to negative 21. Subtract 5. So it looks like we're subtracting 5 for this pattern. And so the next number, if you subtract 5, you're going to get negative 31, negative 36, negative 41. These are arithmetic sequences. That's because on the number 3, I added 10 every time, and on number 5, I subtracted 5 every time. Number 7, we're going to find the recursive formula. Recursive formula. All right, so remember this term because there's going to be a different term here in a minute. Recursive formula wants to do this. A recursive formula wants to find a formula for an, the nth term, or the nth bushel of apples. And in order to do that for a recursive, you need a couple of things. You need maybe the term right before it, and you need the first term. You probably don't need any of the other bushels of apples, but you're definitely going to need the term right before the nth term and the first term. Otherwise, it's pretty similar to what we've done. You can look at the pattern and see the D number. It looks like you're adding 7 to get from term to term, plus 7. So if you think about it, some number off in the future, whatever it is, all right? So let's say it's this bushel of apples right here. What you would have to do is take this one right in front of it and add 7. So put it in terms below the bushels of apples or in the n terms. The nth term is equal to the n minus 1 term, that's the one right before it, plus the first term. All right, so we know the first term. We know the first term. The first term is just this 1, so we can put a 1 there. We don't know the nth term, and we don't know the n minus 1th term, but we do know the first term. So maybe you could skip a step. But this is what we want to say. We're trying to find the nth term using the, oops, I messed that up. Hold up. Back up. We want to find the nth term using the n minus first term plus 1. Now we're going to find the recursive formula. Remember that word. That's important. That's going to tell you what to do and how we do it. So if we think about the bushels of apples and put it in those terms, we're trying to find the formula for an. So the answer is going to be an equals, and we're going to use the term right before it and the first term. Those are the things that we're going to need, all right? So if you look at the numbers in this sequence, you should notice pretty quickly that you're adding 7 to get from number to number. And so whatever number it is off in the future here, in order to get there, you must have added 7 to get there. So think about it in terms of the bushels of apples. For the nth term, you need to take the one right before it, which is a minus 1, and add 7. Now that seems like it's finished, but you have to also tell me where we started. So say a1 equals 1 here. It means you need both of those statements in order to have a recursive formula. If you didn't put that second statement, if you didn't say a equals 1, then you wouldn't, you might have a repeated answer. If I said 0, 7, 14, 21, oh my gosh. If you notice, that's the same pattern. You're taking a number and adding 7, adding 7, adding 7. And so it would be that same top step, but we have to have that second step, a1 equals 1, to eliminate any other possibilities of the numbers. So that's a recursive formula. In order to find that nth term, you need the term right before it, and that common difference, and the first term. So look at the next example. From 14 to 5 to negative 4 to negative 13. Looks like they're subtracting 9, right? So the recursive formula, a n minus 1, and then subtract 9. Second part of this recursive formula, you got to tell me where we start. A1, that's the first bushel of apples. A1 is just this first number, 14. find the explicit formula. This time we're finding the explicit formula instead of the recursive formula. And you see over on the right side in that blue box, that's a formula for the explicit formula. And this is a little bit easier to deal with. It's a little bit better than the recursive formula. If you think about it, the problem with the recursive formula is to find the 100th term, you're going to have the 99th term, and then the 98th term, and the 97th term. And so it's kind of hard to come by the recursive formula because you always have to know the term right before it. For the explicit formula, we don't really care about the terms right before it. We still want to know an, so the answer is still going to be an equals, but this time it's going to be different because we don't need to know the bushel right before it, all right? So if you look at the formula in the blue box, look at what we need to know. We need to know the first term. Well, the first term is just 12 in this case, and then plus. Now, we don't know what n is. N could be 100, it could be 200, so we're just going to leave it alone as n in our formula. So n minus 1. And then the d number, we know about the d number, it's just how do we get to the next number? Plus 10, plus 10, plus 10. So that d number over here is 10. So we actually have our explicit formula already built. The rest of this is just we're going to simplify. So let's distribute that 10. And we would have 12 plus 10, n minus 10. And then look at your like terms there. 12 minus 10 is 2. 2 plus 10, n. So remember, we want an equals 2 plus 10n. That is a formula, an explicit formula for the nth term. That means if we wanted to find the 100th term, we would just plug in 100. And we could find it. We don't need to know the 99th term. We just need to know what n is. If I want to find the 64th term, I plug in 64. Got it. So we can do this over and over again. For the next one, an equals, the first term is going to be 24 plus n minus 1 times d. Let's see, how do we get there? Minus 7. Looks like times negative 7 right there. So again, we're pretty much finished. We just need to clean it up. So distribute the negative 7 there, and you have 24 minus 7n plus 7. And combine the like terms. 24 plus 7 is 31. So an equals 31 minus 7n. That's an explicit formula. Explicit formulas are very useful for finding a term off in the future, like the 99th term or the 57th term or whatever. So 15 is doing exactly that. Find the term named in the problem. They want to find the 26th term. So what you could do is say, all right, I see that first, second, third, fourth, fifth term, sixth term, seventh term. You can see that they're adding 2, and you could just add 2, add 2, add 2, add 2, add 2, up until you get to the 26th number, and that would work. I don't really want to do that, though. What I'd rather do is do what we just did, find that explicit formula, and then plug in 26. So think about the explicit formula. For the nth term, let's look at it again. You take the first term, so the first term is this 23, plus, think about the formula in that blue box, said n minus 1 times d, in this case was 2. All right, now this problem goes one step further because we know what the n number is. This is the n number, 26. So if we're finding the 26th term, we can actually go ahead and plug that in. Now, I'm going to do this part in my head because I know 26 minus 1 is 25. So we're going to have 23 plus 25 times 2, or 23 plus 50 is 73. So we've got a specific number this time, not a formula. The 26th term is 73. That means that's the number that would be in this box, or this bushel of apples. Number 17 is doing the same thing. So we can think about this as the 26th term equals the first term's 34. I'm just going by my formula. Plus n minus 1, or in this case, n minus 1. If n is 26, we can go ahead and say that's 25 if we want, times that d number. So the d number is how you get from here to here to here to here to here to here. It looks like plus 7. That d number would be 7. So we have 34 plus, think about a bushel of apples. So we have 34 plus 25 times 7 is 209. The answer is 209. The 26th term, A26, equals 209. Now again, if you're confused, we went back and we used this formula. AN equals A1 plus n minus 1 times d. That's all it is. AN equals A1 plus n minus 1 times d. You're going to need that formula out, so make sure you write that down somewhere on your paper, because that's what I used. We've already learned about an arithmetic sequence and a geometric sequence, but this time we're going to talk about an arithmetic series. All right, we're still talking about bushels of apples, but this time we're talking about an arithmetic series. A series is a sum. And so if you think about those terms, we see some numbers there. We're trying to find the sum of all of those terms. So what we could do is we could add all the terms and see what their sum equals. In this case, the sum of those first 5 terms is 70, and so that would be the answer to the series. We have just evaluated the series of the first 5 terms. But there's also going to be a formula, and that formula is going to be important, and it's going to be probably better to do than physically adding the numbers. Sometimes there's going to be there are going to be a lot of numbers, or sometimes you won't have all of the information. That formula is going to be very useful. Problem number 1, evaluate the related series of each sequence. So there we see that word series. And you should know that when you see that word series, it means find the sum. And so what you could do is take out a calculator and literally add those numbers together. If you added those numbers up, you'd get the answer. But we want to practice using the formula. So that formula from last school was Sn equals n over 2 times the quantity A1 plus AN. Now, notice there's an S. The very first letter is an S. S stands for series or sum. So that S is what's telling you that you're finding the sum of those terms. So let's talk about what the other letters represent. The letter N in this problem is how many numbers there are. So I see 1, 2, 3, 4, 5, 6 numbers. N is 6. And then A1 is just the first A number, the first term. And AN, in this case, there are 6 numbers, so that's like A6 is the last number. And so to evaluate this series, we just need to calculate that. So let's go to a calculator, and let's see, 6 over 2 times 31 plus 71. 306. That's the sum. The answer is 306. Incidentally, that's what you would get if you added up those numbers. So then the next one, we're going to do the same thing. Evaluate the series. Find the sum. Sn equals, in this case, I see 5 numbers. The first number is 15, and the last number is 27. So all I have to do is calculate that. You can do the order of operations and do that by hand if you'd like, but I'd rather use a calculator. 5 over 2 times 15 plus 27 is 105. So your answer is 105. Evaluate each arithmetic series. So again, we're talking about a series, we're talking about a sum. It's the same problem. Now the difference here is you wouldn't be able to add those numbers up. I know in the last problem, sometimes people just say, well, I'll just add up the numbers. I'm not going to learn the formula. But in this problem, you have to use the formula because you don't know what all of those numbers are. It would be impossible for you to add them up. So here's the formula for the sum. You notice they give you all of the numbers here. So the sum is n is 6 in this case. So 6 over 2. And a1 is 11. And an is 46. So very straightforward. They give me all the numbers here. I'm going to calculate that. Is 171. Next one, same thing. We're going to do 8 over 2 times 26 plus 96. Nothing tough here, it's just a calculator problem. $488. And then the next one, plus 248. Okay, we did it. We evaluated those arithmetic series. When students see problem number 11, they see that weird symbol and their brains kind of start shutting down, okay? But I want you to pay close attention because it's not that difficult. That symbol is one of the Greek letters of the alphabet. So as you look at the Greek alphabet, you can see some similarities to our alphabet. A, B, okay, there's, I guess, C, D, E. You can see some things, but find that symbol in the Greek alphabet. You see that it's called sigma. This is the Greek letter sigma. So don't be confused. This symbol just means the Greek letter sigma. But that's kind of like our letter S. And if you think about it, our letter S was talking about a series, which is talking about the sum. So when you see that symbol, sigma means series or sum. So what we're trying to do is find the sum of the first 6 terms in that sequence, or the 6 bushels of apples. And I know it's the first 6 because these numbers over here on the left are numbered from 1 to 6. So it's like bushel 1, 2, 3, 4, 5, and 6. So what we're going to do here, what they're telling me to do, is plug in these numbers from 1 to 6 into this little formula right here. All right, so think about that first term. That first term, we're going to plug in 1. And so if you plug in 1 into this k right here, this k value, 3 times 1 minus 2 gives me 1. And then we're going to plug in 2, and then 3, and 4, all into that same formula, and 5, and 6. So we can plug in the numbers from 1 to 6. But remember that letter sigma was the letter S, standing for series. So really what we're doing is finding the sum of those terms. So the answer to this problem is 51. We found the sum of the first 6 terms of that formula adds up to 51. But don't forget about our formula. we have this formula, and this formula is actually more important. You're actually not going to want to add up all 6 of those terms. I know it might seem easier for you to add those 6 up, but if we use the formula, we really only need the first term and the last term. And so think about how that's going to work. Just like the older problems, the other problems that we've done, Sn was equal to n. I know n is 6 here because there are 6 terms, or 6 bushels of apples, over 2 times a1 is that first number there, 1, plus an is the last number here, 16. So we just have to evaluate that formula. You have 6 over 2 times 1 plus 16. And that's 51. Same thing. So we can find all the terms and add them up, but it's going to be easier, trust me, to use the formula. Check out this next example, number 13. And number 13 goes from 1 to 30. So if you think about it, if we were going to do what we did a minute ago, we'd have to plug in all of the numbers from 1 to 30 and then add those numbers up. Well, I don't want to do that. All I really have to do is find the first number and the last number. So here's our formula. Sn equals n over 2 times a1 plus an. And let's just think about those numbers that are going to go in the formula. Well, n is 30. There are going to be 30 bushels of apples. And then a1, well, I don't know a1 until I plug it in. So let's find a1 by plugging in that first number. 7 times 1 minus 6. That's 7 minus 6 is 1. So there's a 1 goes right there. Plus an is the last number, and you're going to find that by plugging in that top number, 30. So you'd have 7 times 30 minus 6. 7 times 30 is 210, minus 6 is 204. Of course, you could use a calculator for that. 7 times 30 minus 6, 204. But that's what goes in over here. And so we're doing the same thing. We're finding that formula, 30 over 2 times 1 plus 204. Is 3,075. I sure wouldn't want to have to add up 30 numbers and get up to 3,075, but that's the answer. So then the next one, we do the same thing. We're using this formula over and over again. So we can see that n is 20, and then we need that first term, so plug in 1. 2 times 1 plus 5, that's 2 plus 5 is 7. And then we need the last term, so plug in 20. 2 times 20 plus 5, that's 40 plus 5 is 45. And then evaluate that formula. 20 over 2, 7 plus 45. It's 520. So that sum is 520. There you go. So don't be scared of that Greek letter sigma. It's not that bad. You can do this.